My name is Adibuddin Ahmed, working as an assistant professor, Department of Electrical Engineering in Institute of Engineering and Technology, Lucknow. So, as you know that we are discussing the very important and very essential subject as concerned with the competitive exam and the general protection. So, that is power system protection. So, in the previous lectures, we have already discussed what is the power system protections, what are the need of power system protections, and some basic terminologies of the protection system. Now, we are going to discuss, this is a lecture 3 of power system protection. Now, we are going to discuss our next lecture. This lecture is basically dedicated to zones of protection. So, let us start. So, now what are the zones of protection of the system, power system, that is the zones of protection. So, in electric power system is divided into several zones of protections. Each zones of protection contains one or more power systems elements and some circuit breakers. So, these type of protections having some structures, or you can understand these type of protection zones created in the power system. So, when a fault occurs within the boundary of a particular zone, the fundamental responsibility of that zones is that the protection of this zone wants to eliminate this zone from the rest of the power system. So, only this zone is disconnected from the rest of the power system. The circuit breakers inserted between the zones of protection and the rest of the power system, so that circuit breaker will operate, and after that operation of circuit breaker, this zone of protection is isolated from the rest of the healthy system. So, in this figure we can easily understand what are the zones. So, suppose we have some generator and we have some elements between these generators. So, we have some power system elements, we have some transformers, we have some circuits. So, in this protection system or in this zone, we have some all the elements between the systems. So, this whole power system is divided into several zones, like this is a zone 1. Zone 1 consists of the generator and the transmission lines and the transformers and other auxiliary equipments connected through a bus bar, this bus bar with this circuit breaker. So, this zone is connected through the rest of the system with this circuit breaker. Now, if we are talking about the zone 2, so zone 2 having the protection of this bus bar, you can say the protection of this section, and this protection of this section is consist with the help of these two circuit breakers. So, we have two circuit breakers. Now, further we have zone 3, zone 3 having a two circuit breakers, and between these two circuit breakers all the equipments of the zone 3 will lie. We also have zone 4 and zone 5. So, each of the zone is divided into another, or whole power system is divided into several type of zones, and this zoning is very important because we want that responsibility of a particular zone is based on the circuit breaker or the protection scheme related to that particular zone. For example, if there will be any type of fault, suppose there is a fault between these two circuit breakers. So, the fundamental responsibility of these two circuit breakers is to eliminate this fault and eliminate these zones from the rest of the healthy power system. Suppose we have some earth fault at that point. So, what is the main responsibility of these protection system of this particular zone? So, zone 5 having a protection system in which we have this circuit breaker and this circuit breaker. So, immediately these two circuit breaker will operate. So, this zone 5 is eliminated, or you can say cut off from the rest of the whole power system. So, you can say now this is healthy power system and this is faulty power system. After that, when fault is cleared, this zone 5 is also again connect with the previous power system network. So, this is the some zoning. Now, thus the location of the circuit breaker helps to define the boundaries of the zone. So, very important that how we can determine the zones. The zone is always determined with the help of the placing and location of the circuit breaker. Different neighboring zones of the protection made to overlap to each other. Very important point that we always having some overlapping. Wow. Suppose we have this type of overlapping. So, this section is consist or will lie in zone 2 and zone 3 both. If you are talking about this section. So, this section is lie between zones 5 and further zone 6, or you can say zone 7, and this section, if you are talking about this section, so this section will lie in zone 3 and zone 4. So, this is a common section. Why we are going to overlap? Because we want to ensure the maximum safety. Because suppose let us example that we have some line and we have some circuit breakers. Suppose now this circuit breaker having such type of zone, zone 1 and zone 2. Suppose if a fault occurred between this point, so that is zone 1, that is zone 2. So, if a fault occur at that point, so this will cover by the zone 1. If a fault occur at that point, this will cover by the zone 2 and this will cover by zone 1. But if a fault will occur on that point, this is a isolating point, or you can say this point will not lie in zone 1 and zone 2. So, what protection scheme will responsible to recover this fault, to protect the whole power system with this fault? No one. That is why, because we have some dark spot, some blind spot in the power system, so that this section is not covered by any type of zones. That is why we want to eliminate this situation. So, that what we have done that one, suppose the same previous. So, what we have done? We have created, this is zone 1 and also have this is zone 2. So, now zone 1 and zone 2 will overlap for this particular section. That is why we want to overlapping. So, ensure that there will be no such a space there or unleft, or there will be no protection scheme responsible for that. So, we want to eliminate such type of location or such type of section which is left for the protection in the power system. However, occurrence of the fault with the overlap region will initiate by tripping sequence of different circuit breakers. So, this is very important that we want to, for example, suppose we have some fault. So, the overlapping section having a different type of circuit breakers, like that we have this type of circuit breakers. So, this circuit breaker section or this section will lie in zone 4 and zone 5. Suppose a fault is occur on that point. So, what zone of protection will respond first? So, this is having some patterns, some sequence. So, we have decided that if a fault is occur, so first this circuit breaker will operate and after that this circuit breaker will operate. So, this is having some sequence. So, we decided some sequence of some pattern so that minimum number of circuit breaker will operate to remove this fault. Now, we are moving forward, we will discuss the type of protection. So, type of protection are basically we have a two type of protection. One type is primary protection and one is backup protection. So, the primary protection scheme ensure that the fast and selective clearing of the fault within the boundaries of the circuit element that the zone is required to protect. So, the primary protection is the rule is provided for each section of an electrical installation, however, the primary protection may fails. So, primary protection is basically fundamental protection. Suppose we can take this example again. In this example, we have a zone first. So, if any fault is occur between these 2 points, between this point, this is a fault. So, very high amount of current will flow through the earth. So, what will happen? The responsibility to protect this whole power system through this fault is based on this circuit breaker, because this is the primary backup or primary protection for this fault. This is the primary protection. Now, if this primary protection is fails, some condition is occur or some failure is occur, so that this circuit breaker will not operate. So that this is the responsibility of that circuit breaker to operate after this circuit breaker. So, this circuit breaker will behaves as a secondary protection, or you can say the backup protection for the primary section or this primary circuit breaker, or you can say, for suppose we want to ensure this zone of protection. So, this zone is responsible, the protection of this zone is responsible basically this circuit breaker for primary protection, and if this circuit breaker will fail, so now this circuit breaker will operate and this circuit breaker will act as a secondary or backup protection for this circuit breaker. So, this is the fundamental basically the primary and backup protection, but somehow the primary protection will fail. These are some points so that the primary protection can fail. The current and voltage supply to the relay may be failure, and the DC tripping voltage supply may be failure, maybe some breaking of wires, wear tear of wires, some losing of wires may be occur. That is why supply failure is very common. Protective relays can fail, so that the fundamental duty and the fundamental property of the relay may destroy, so that relay will not act. After that, tripping circuit having some problem, and circuit breaker also have some problems. So, that these are the some list of problems. So, that is why the primary protection fails, somehow the primary protection does not work. So, if primary protection does not work, then secondary protection is line up. Now, moving, that is the backup protection. So, backup protection is what? Backup protection is a name that is given the backup to the primary system. So, when primary system fails, backup system is ready. Backup system is, you can say, the second line of defense. Suppose we have some war front. So, this is the first war front, this is the first line of soldiers. Suppose we have some kingdom. So, this is the first line of defense. Suppose we can understand that with this example. The enemy is coming from this side, and we have this kingdom, we want to protect this kingdom. So, this is the first line of defense, and this is the second line of defense. So, this is second and this is first. The first line of defense is responsible to operate first, but when first line of defense is not working or first line of defense fails to work, the second line of defense will work, but the condition is that second line of defense always work after the failure of first line of defense. So, that we have some time difference between first line of defense and second line of defense. First line of defense of primary protection will always act instantaneously or first. After that, when primary protection fails, the secondary protection or backup protection will act. So, the backup protection, the design of backup protection needs to be coordinated with the design of the primary protection, and essentially it is the second line of defense after the primary protection fails. So, that is very important. We have some timer settings, so that one protection is fails. So, we include some secondary options, some backup protection for this protection of this zone. So, we have some graded protection, or we can say some line up protection. One circuit breaker is primary protection or primary responsible for the protection of that zone. After that, we have some another circuit breaker. So, these are also responsible to protect this zone. Now, we will discuss these desirable qualities of the protective relaying. So, the fundamental requirement of the protective scheme as follows. These are the some desirable qualities that our relay scheme must have. First is reliability. Reliability is very important. Why? It is ability of the protection system to operate correctly. The reliability features has two basic elements which are dependability and security. So, first we will discuss what is the dependability. Dependability features demands the certainty of the correct operation of design system on occurrence of any fault. So, this is the clarity of the correct operation. Correct operation means suppose fault is occur, so the right circuit breaker will operate at right time. Right circuit breaker operate at right time. You can say the appropriate circuit breaker. We don't want to operate all the circuit breaker at a time. No, we have some selectivity. We have some decisions. So that if fault is occur at the section, we want that minimum number of circuit breaker will operate. We doesn't want that all the circuit breaker will operate. Second property is the security. Security features can be defined as the ability to design system to avoid incorrect operation during the fault. So, we want to avoid the incorrect operation during the fault. So, we doesn't want that fault is occur at any section, but the circuit breaker will operate of the another section and having a some time mismatch. So, we don't want this condition. So, that is why this is called the reliability of the system. System will highly reliable, so that appropriate circuit breaker having a minimum number of circuit breakers will operate at a particular time. The factors which affect the features of any protection system depends upon the sum of the following few factors. What are these factors? That is the quality component use. The highly capable, highly quality, highly graded material component or component will use for the protection. We doesn't want to use some low grade material. Maintenance schedule. The maintenance is very important because wear and tear and the you can say depreciation of the material always occur. If you select a very highly graded material, still the wear and tear and the you can say the demolition of that material or depreciation of the material will always occur. So, that the maintenance schedule is very important. The supply and availability of the spare parts, because spare parts and stock, spare parts is will always available. Why? You have to some stock of the spare part, because at the any situation some spare part can fail. So, we doesn't want to lose our continuity in the supply system. The design principle is very important. So, that we want some compact and some reliable design, so that this design will not fail after the operation. Electrical and mechanical stress to which the protective part of the system is subjected to. So, electrical mechanical stress is very important point, because in this relaying scheme we have some high voltage, we also have some mechanical stress. So, that these two stress, electrical and mechanical, lead to failure of the system. That is why we want to have a sub high quality system, so that which have some high stress capability. And now, second of desirable quality is fitness of operation. So, protective relay required to be quick acting due to following reasons. Fast response, fitness of operation means the fast response, fastness in operation. So, that is very fast response. You can also call this point that speed of the protection. So, protective relay are required to quick acting due to following reasons. What are these reasons? Critical clearing time, said that the critical clearing time should not be exceeded. Critical clearing time is related to the stability of the power system. We doesn't want to increase our critical clearing time. That is why we want that the fast or the fault clearing time will minimize or will be very minimum, or you can say the fault clearing time must be very minimum, so that we want to eliminate or we want to save maximum of the power system without damage or with minimum damage. Electrical apparatus may be damaged if there will be fault, and this high value of current will persist for a long time. suppose we have some transient, also these transients will make a problem in the system, but also that high value of current will permanently damage all the system. So, this high value of current will surely interrupted with the help of some circuit breaker system or some relaying system. So, fastness of the operation is very important. The persisting fault will lower the voltage, because continuously fault is persisting, so that this continuous persistence of the fault will lowering the voltage, because we have some voltage drop. That is why some operation or at the load point the crawling and the overloading of the industrial drive will occur. That is very important. So, that we want to reduce or we want to eliminate this fault as quick as possible. On the other hand, relay should not be extremely fast, so that the relay will operate for transient condition. Maybe the relay will operate on transient condition, because if the relay is very highly sensitive, transients always occur in the power system, these are the not fault, these are the transient, these are the switching conditions. So, that relay will operate according to this transient. So, relay will not be stable in the power system protection, relay will always trip after some time. So, that produce some instability in the power system. That is why the relay will not too sensitive or too fast to detect the transients in the power system. Now, the selectivity, very important point, that is selectivity. The features aim at maintenance of continuity of the supply system by disconnecting the minimum section of the network necessary for to isolate the fault. So, we have some, you can say, some decision making, and this decision making is what we want to ensure the minimum number of the circuit breaker operate, so that we have ensure the continuity of the power system will not affected. Let us some example. Suppose we have this line, we have some generator and we have some load. This is a generating section or this is some load. So, if these are the circuit breaker 1, 2, 3 and 4. If a fault is occur, so if there is a fault at that point, so we have we also have some circuit breakers at the side. If a fault is occur on that point, we have some different type of opportunities. We can operate the circuit breaker 1 and 2 to protect this fault, that is okay. We can operate the circuit breakers at these 2.5 and 6. So, this also okay. So, now if we can say we can operate the circuit breaker 5th and 6th, and we can also operate the circuit breaker 1 and 2. So, but we doesn't want to interrupt or continuity of the supply system. So, if a fault occur at that point, we can surely select the circuit breaker 1 and 2 to operate, because if we operate the 1 and 2 circuit breaker, this section is isolated from the rest of the healthy system. Also, we have some another path, so that the continuity of the supply will not fail, so that the 3 and 4 will operate continuously, because we have some another path. So, that this section is okay and the generator and the load section also is connected. So, that is very important. That is selectivity. We want to ensure that the minimum number of circuit breaker will operate at a time, so that the continuity of the system will not break. So, this is the main selectivity problem. Now, the sensitivity. The sensitivity of a relaying refers to the smallest value and the smallest value of the actuating quantity at which the relay operates during the abnormal condition. So, sensitivity refers to the smallest value of the actuating quantity or smallest value of the error. So, that at this point the smallest value of the error will operate and the smallest value of the error. So, that this error will transform at the output stage. So, this error will transform the output stage. So, you can say the sensitivity is smallest value of error can detect by the relaying system. In case of overcurrent relay, the mathematically this can be defined the ratio between the short circuit current and the operating current I/O. So, the value of I/O should not be too small or too large, so that the relay is either too sensitive or slow in corresponding. So, this is you can say the smallest value in the fault current will reflect the particular action of the relay or operation of the relay. So, when the relay is too sensitive, with the help of a small value of current or with the help of some small fault can operate this relay. So, this is the ability of the relay, or if the relay is not more sensitive, high value of fault current is not detected by the relay. So, this is called the failure of the relay. So, the relay is not to be very slow and not to be very fast. Stability, it is the quality of the any protection system to remain stable with a set of defined operating scenarios and procedure. So, we have some bias scheme of differential protection is more stable for towards the transient as compared to the merge price protection scheme differential protection. So, we have some stability problems. Stability problems occur when we have some switchings, see continuous switchings, or we have some transient condition. So, in transient conditions some relay will not in stability point of view, some relay will not stable and these relay will leads to the unstable the whole system. That is why we want that our relay must be stable in the transient condition also. So, if transient condition is occur, the relay will not operate. The relay can understand this is the transient condition and this is the faulty condition. And adequacy. Next property is adequacy. It is the economically unavailable to be protect the 100% of the entire system. So, therefore, the cost of the design protection system varies with the criticality and importance of the protected zone. Suppose we have some different type of protection, we have some bus bars, we have some transmission lines, we have also have some generator in the transformer. So, each section having its criticality, having its importance, having some different type of protection and the cost of the protection is very different from the other. Suppose transformer having a very high cost of protection rather than the some circuit breaker of protection. So, that is why we call this adequacy. So, we does not want that same cost of protection is available or is put on whole the protection system, because transformer or some element can have some different type of protection or more complex type of protection. So, each system is protected with some adequacy of protections. We does not want to protect a very cheap element with highest cost of the protection. We want to protect the highest cost element with highest cost of protection. So, that is why we have some different patterns. Some element is protected with highest cost and some element is protected with fundamental protection schemes. So, that is it's about to lecture 3. In next lecture, we will discuss for the next topics of the power system protection. Thank you so much.